number, given numbers from 0 to n range, and our goal is to figure out which one is missing. So in this case, 0, 1, 2, and 3 it's missing. In this one is there is a 0, 1 because there's a 2 entries in here, so 2 is missing since there are 2 numbers. So all numbers in range 0 to 2, 2 is missing number in the range since it doesn't appear in nums. So previously we have solved this one with bit manipulation where we were using XOR. In XOR we were just going by the length of the number, and we were getting all those XORs, and then for a given numbers we were doing XORs again, and then the last XOR, it was our answer. Time complexity was O of n, and space complexity was O of 1 in this case. I want to solve it with a different approach where I want to use a cyclic sort pattern. So in cyclic sort pattern, basically since it's in a range, what we are going to do, we will be swapping in place and then trying to put it in the right indexes. And then later from their side we can just like find which one was the missing number. So let's jump into coding right away and use our cyclic pattern. So the goal of the cyclic pattern, try to put in the right place. So how are we going to achieve that? We will need to have an iteration. So let's create our iteration. Initially let's do k 0, and while k is smaller than nums length, let's do the iteration. So this is from 0 to n range, and what we are going to do is that we need to find the correct ID that it was correlated to. So for given nums k, this is our correct ID. So let's say in this first iteration, so when we are looking at this first number right here, we say this is a correct ID, so we will put it in the correct place of it, and then we will say, because like the goal is to be equal to each other, so when it's 0 here, at 0 they need to be equal. So we'll say if, and then just to take care of the out of boundary, we need to make sure if correct ID is smaller than nums length first, and do our checks. So if nums k not equals to nums correct ID x, then swap them. So in this case, this one was larger than this one, so we will get skipped. So when we are at this stage, because correct ID becomes 0 and k is 1, so at this 0 we have correct ID 3. 3 is not equal to 0 at this k, so we will do the swap. So temp, we will just get a temporary value. We can get the k first, and then we'll say nums correct ID x equals to nums k, and then we'll just say nums k is equal to temp. So nums k, we put it in our temporary value, which is holding the value in here, and then for correct ID we took the value of the k, and then overrode it in corrected IDX. And now for nums k, we need to, so this is going to be here. So initially we stored our correct value in here, and then for correct value we overrode it with the k number. Now for k number we need to override it with the corrected ID. So we did the swap in here. So else we'll just do incrementation of this k incrementation. So we'll just keep going with the next iteration. So once we have it, this in here will be sorted as 0, 1, and 3. And then what we can do is just like loop through it again and then see which doesn't match with what. And then at that position, that will be our answer. So let's go through the iteration of it. So for int I equals to 0, I smaller than nums length, I plus plus. And then what we are saying, if for given nums I, if it's not equals to with I, which is our number, then return I itself. And if it doesn't go through with this, then we can see that in this loop everything went through like 0 to 1. We didn't get to this level. However, we needed to return this 2 since there are two numbers, so that will be the length of the array. So let's run our code. Perfect. So in this approach, time complexity is O of n, where n is the length of the nums array, and space complexity is constant O of 1.